6.3 Geometric Sequences in Series. Well, we've talked about arithmetic sequences in series, but a geometric sequence is a sequence where there's a ratio between the successive terms, where you're multiplying by the same thing. And that common number you multiply by is your common ratio. That's called R. So in arithmetic sequence, we added the same thing. Well, in geometric, we multiply by the same thing. So like on number 1, to get from 3 to 6, and to 6 to 12, and 12 to 24, we're multiplying by 2 each time. So this is a geometric sequence. And if it's geometric, it has a common ratio, and the ratio is 2 that we multiplied by. That was a times 2. And this was a times 2 and times 2. Well, on number 2, I look and I see 5 fourths, 5 twelfths, 5 36. Well, the numerator stays 5, but 4 times 3 is 12. 12 times 3 is 36. So we're multiplying by 1/3 each time. So since we're multiplying by the same amount, that's our common ratio. And that means, yes, it is geometric. On number 3, I look and we have 1 and 2 and then 4. Well, multiplying by 2 gets you to here, multiplying by 2 gets you to here, but 4 times 2 does not get you to 7. So let's see, is it arithmetic? We add 1, we add 2, we add 3. It's not even arithmetic. It is not geometric, and it's not arithmetic either. Not geometric. Number 4, 896. Well, to get to 224, if I take 224 over 896, I could figure it out, or 56 over 224. When I look at it, it's easier to look at these two. 14 times 4 gets you to 56. 56 times 4 gets you to 224. We're dividing by 4 each time, which means we're multiplying by 1/4. So this is geometric because we're multiplying by the same amount, and the amount that we're multiplying by is 1/4. Let's look at number 5. Well, number 5, they told us what the pattern's doing, but they didn't give us the first term. So let's figure out the first term. So the first term would be 3 to the 1/10. The second term, n becomes 2, so it's 3 to the 2/10. The third term is 3 to the 3/10. And then that pattern continues. So is that geometric? Are we multiplying by the same thing? Well, I asked this question in class, and a lot of people looked at it and went, nope, that's not. We're adding a 1/10 each time. But if you think about that, 3 to the 1/10, if you multiply by something with the same base, the bases stay the same, and you add the exponents. And if I multiply by 3 to the 1/10 again, the bases stay the same, and you add the exponents. So 1/10, 2/10, 3/10. So we multiplied by 3 to the 1/10 each time. So yes, it is geometric. And the amount we multiplied by is 3 to the 1/10. Now, to give you a hint on that one, this is 3 to the n over n divided by 10. Well, that's 3 to the 1/10 to the nth power. If you ever see a sequence that's exponential, with a power that's the exponent, the base is your common ratio. That's our R. So it'll be a geometric sequence, and they told us what R is. Well, let's look at number 6. So to find the first term, 4 times 1 squared plus 1 is 4 times 1, which is 4 plus 1 is 5. To get the second term, we do 4 times 2 squared plus 1, which is 4 times 4 plus 1, which is 16 plus 1, or 17. To get the third term, it's 4 times 3 squared plus 1, which is 9 times 4 is 36 plus 1 is 37. We're not multiplying by anything, and if you can always double check that. If the first ratio is 17 divided by 5, well, the next one is 37 divided by 17. Those are not the same thing. If this were geometric, those would have to be the same ratio. So this one is not geometric. Moving on to number 7. The instructions say this time to write the first 4 terms and then decide whether it's arithmetic or geometric. If it's arithmetic, we're going to find the common difference. If it's geometric, we're going to find the common ratio. Well, the first term on this one would be 4 times 1 minus 3, which is 4 minus 3, which is 1. The second term is 4 times 2 minus 3, which is 8 minus 3, which is 5. The third term is 4 times 3 minus 3, which is 12 minus 3, which is 9. And then the fourth term is 4 times 4 minus 3, which is 16 minus 3, which is 13. And if you look, we went up 4 every single time. So we added 4, so this is an arithmetic sequence. Arithmetic. And since it's arithmetic, we had a common difference, and that common difference we increased by 4 every time. Number 8. Well, let's figure out the first term. The first term is 3 times 1/2 to the 1 minus 1. Well, 1 minus 1 is 0, so that's 3 times 1/2 to the 0 power. Well, anything to the 0 power is 1, so that's 3 times 1, or just 3. The second term is 3 times 1/2 to the 2 minus 1, which is just 3 times 1/2 to the 1, which is just 3 halves. The third term is 3 times 1/2 to the 3 minus 1, or 3 times 1/2 to the second power. And that's 1/2 times 1/2 is 1/4, so that is 3/4. Well, if you look, 3 halves, 3/4. The fourth term, you should be able to figure this out by now, but this is going to be 3 times 1/2 to the 4 minus 1, which is 3 times 1/2 to the third. 1/2 to the third is 1/8, so that is 3/8. Hopefully you've noticed that this pattern was multiplied by 1/2 every single time. And since we're multiplying by the same value, that tells me it's a geometric sequence, and that r is 1/2. And you remember me saying, if you have an exponential function raised to an exponential function, the base is the r. Okay, let's move on. Well, to find any term in a geometric sequence, there is a formula for that. And that formula says, to find the nth term, you take the first term, that's a sub 1, they just call it a for some reason. And then we take and multiply that by the ratio to the n minus 1 power. So, for this number 9, to find the nth term, we're going to take the first term, which is 3, times r, which is -5, and since we're going to be raising a number to a power, a negative number especially, put it in a parentheses, and we're going to raise it to the n minus 1. Well, there's our formula. There's the nth term. There's nothing we can do to that formula. But to find the 10th term, a sub 10, we're going to take 3 to the -5 to the 10 minus 1 power, which is 3 times -5 to the 9th power. And without a calculator, that's the best I could do. I'm not going to try to do -5 times -5 times -5 9 times. But this is one of the few times we're going to let you use a calculator on the assignment, and I think even on the test. So I need to know what 3 times -5 raised to the 9th power is. And here it's important to put a parentheses around a number to a power with the power on the outside of the parentheses, because especially an odd one won't matter as much, but if that's an even power, you can get a wrong answer if you're not careful. So that is, oh, it'd help if I put it where you could see everything, huh? Let's see, can I move this? Here, I can move it this way. There, now you should be able to see. It is negative, what is that? 5,859,375. I wonder if I could copy that, because I'm too lazy to, nah, I'm not even going to try. So we'll just move on to the next problem. You saw the answer. It was on the other screen. To get number 10, oh, should I go ahead and be nice and write it for you? Negative. So 5859375. Negative 5859375. And that was it. So I'm double checking myself here. So yep, negative 5,859,375 is your answer. So number 10. If you want to pause the video and try to work out 10 and 11, you do that, and then you can come back and I'll be calculating these. So to get a sub n, I'm going to take the first term, which is a, which is 100, and I'm going to take my r, which is 1/4, and raise it to the n minus 1 power. That'll give us any number in any sequence, any number in this sequence. To get the actual 6th term, I'm going to take 100 times 1/4 to the 6 minus 1, which is 5. And that's 100 times 1 over 5 to the 4th power is 1,024. I did this one earlier. And then 1,024 you can divide by 4 out of the top and the bottom. And when you do that, you get 25 over 256. Yes, double checking my math. And that's what you get on that one. On number 11, to get the nth term, which is all they're asking for in this one, we take the first term, which is 9, and look at the common ratio. From 9 to 3 to 1, we're dividing by 3 each time, or multiplying by a third. And then we say n minus 1 power. So the common ratio is 1/3. N minus 1, we're done with the front side of these notes. So let's move on to number 12. On number 12, we're talking about a car's value depreciates at an average rate of 12% per year. If you bought the car today for $32,800, what would be the car's approximate value 5 years from now? Well, A sub 1 is going to be $32,800. So A sub 1 was $32,800. Well, our interest rate, if it's depreciating at 12%, well, if we're going down 12%, well, if you think of that as a decimal, that's 0.12. Well, if you're decreasing by 0.12, 1 minus 0.12 is 0.88. That's our R. We're increasing by 0.88. It's less than 1, so it's getting smaller. And N, this is the one that messed me up when I first looked at these problems. A sub 1 is right now. So 5 years from now means we're going to add 5 to that. We're actually looking at A sub 6. So N is equal to 6 in this situation. Hold on, I'm going to close the door. Hopefully it's a little less background noise now. So we're going to use our same formula where A sub N is equal to A times R to the N minus 1 power. So A sub 6 is going to be 32,800 times R, which was 0.88 to the 5th power, to the 6 minus 1. And that one I'm not going to try to do by hand. So 32,800 times 0.88 raised to the 5th. And you get $17,309.61. So $17,309. $17,309.61, and that is the cost for 5 years from today. So just a reminder, if it ever says, like on a problem like saying, at the end of the day, well then you're going to include that number, so then it would be, your N would be one more than what you think. But if they're just saying on that day, then N is what you're looking at. So moving on to a geometric series. Well, the difference between a sequence and a series, remember, is that we're adding for a series. Well, the only difference now, the term we're talking about are geometric, so we're multiplying to get the series, to get the geometric pattern, the sequence, and then we're going to add them together to get the series. So, looking at this one right here, I see there are 1, 2, 3, 4, 5, 6, 7 terms, so N equals 7. I know my first term is 2, and from 2 to negative 4 to 8 to negative 16, our common ratio is negative 2, so we're multiplying by negative 2 each time. So to get the sum of the first 7 terms, well, you could add all these up by hand, which is very doable, and since you're allowed to use a calculator, you should not get these questions wrong. But I'm going to show you the formula. The formula says to get the sum of the first 7 terms, we're going to take the first term, which was 2, and then we're going to take 1 minus our common ratio, and I'm going to put that ratio in a parentheses so I don't get a mess up on my signs, and raise it to the nth power. So that is the 7th power. And we're going to divide all that by 1 minus R, which was negative 2. So you could type that in on the calculator, but I'm going to do this one by hand. 1 minus negative 2 is 1 plus 2. That's 3 in the denominator. We have a 2 there. And 2, whoops. Sorry. If I'd have known that was coming, I would have paused it, but I didn't know, I wasn't paying attention. So 2 to the 7th is 128. So that is 1 minus, and a negative to us, the odd power is going to stay negative, so minus a negative makes it a positive, so 128. So that is 2 times 129 all divided by 3. Well, I can't do 2 divided by 3, but I can do 129 divided by 3, and 129 divided by 3 is 43. And then there's still times 2. So the answer to this without a calculator is 86. Or you could have typed it in and gotten that a whole lot faster than me. For number 14, on average, tuition rates for colleges increase about 8% each year. Well, if it's increasing by 8%, that means our R is going to be 1 plus, that's a decimal is 0.08. So 1 plus that 0.08, so 1.08. Remember, to be bigger than 1, you add it to 1. To be less than 1, you would subtract it. So if you're increasing, you're going to do 1 plus. If you're accepted into Baylor and you plan to pay about $47,000, so our first term is $47,364 for the first year. How much should you expect to pay for 4 years? Not at the end of 4 years, and that's going on to 50. It just says N is 4, so it's for 4 years total of school. So we're going to use that sum formula. So S sub 4 is equal to the first term, which is $47,364, times 1 minus our R, which is 1.08 raised to the 4th power, and divide that by 1 minus R, which was 1.08. And we're going to type that in on the calculator. And I'm just trying to grab my notes to make sure I don't make a mistake, because when I'm on the other screen, it's easier for me to see. So, my calculator, I need control divide. I'll go ahead and put the fraction up there. I've got 47,364 times 1 minus 1.08 raised to the 4th power. And my denominator is 1 minus 1.08. And you get $213,427. And, well, it's actually 48 cents. They round, for some reason it rounded it to a 5. I'm not quite sure why. So $213,427. So $213,427. I'm not worried about the pennies when you're talking about that much money. So there's our money. And the last one. To get the sum of the... Okay, final interruption. So for this one, a summation says we start at this value, and we plug that into here. So the first term, a sub 1, is going to be 1/3 to the 1 minus 1 power, which is 1/3 to the 0, and anything to the 0 power is 1. And we're going to continue down to the 4th power. I'm going to go and get the second one so we can talk about what the ratio is. So this is 1/3 to the 2 minus 1, which is just 1/3 to the 1, or 1/3. So since we went from 1 to 1/3, our common ratio was 1/3. Now, you could go ahead and do a sub 3 and a sub 4 and add them all up and get our answer, and that's perfectly acceptable. But we can also use our summation form that we just talked about and said, since we're trying to find the first 4 terms, the sum of the first 4 terms, sigma means we're going to do a summation, which means we're adding. We take the first term. The first term was 1 times 1 minus our R. Well, our R was 1/3, and 1/3 raised to the n power, which was 4, all divided by 1 minus R. So you can type that in on the calculator. I'm going to go ahead and do it without a calculator. 1 times anything, I don't need the 1. So 1/3 to the 4th power is 1 over 81. So we have 1 minus 1 over 81. 1 minus 1/3 is 3/3 minus 1/3 is 2/3. And that's 81 over 81 is the same thing as 1. So that is 80 over 81 divided by 2/3. And if you remember fractions, you keep it, change it, flip it. 80 over 81, we keep that fraction the same, change that to time, and flip that one over. That's 3 over 2. 3 goes into 81 27 times. 2 goes into 80 40 times. So we end up with 40 over 27. But you didn't have to do that by hand. You could have done it on the calculator. That is everything you need to know to be able to get the 6.3 assignments done. And we made 2 assignments out of 6.3, so there's an A and a B. So make sure you can do both of those. Good luck to you.